So in this video, we're going to talk about some linear inequalities, how you solve them, how you graph them, and then how you can write the answer in interval notation. So I'm going to go ahead and zoom in on the first problem here because this whole mess looks like a mess, but we're going to break it down in pieces and hopefully simplify this problem pretty quickly. So the first thing I want you to do is to simplify the left and the right sides of your inequality. And so in this case, I'm going to need to do distributive property. So I've got 6x plus 3 minus 4x minus 10 is less than 15x minus 10. Okay, so let's keep cleaning up. And in this case, we definitely have some stuff on the left side that are some like terms. So 6x minus 4x is 2x. I was going to say negative 3. It's not negative 3. It's 3 minus 10 is negative 7. All right. Strictly less than 15x minus 10. Now, at this point, you're going to make a decision. You are either going to put your variable on the left side or you're going to put your variable on the right side. I'm going to make a recommendation. I'm going to recommend that you put the variable on the left side. You don't have to, but it makes reading the inequality later on easier. So that's actually what I'm going to do. So I'm going to go ahead and subtract 15x from both sides. And as I'm subtracting 15x, I'm also going to add 7 to both sides. So 15x minus 15x cancels. Negative 7 plus 7 cancels. I've got negative, what would that be? 13x is less than negative 3. Okay. Now, this is where you need to be careful because we're about to do a division step. And in this case, we are dividing by a negative. So when you divide both sides of an inequality by a negative, the inequality symbol has to flip. All right? And that's true when you multiply or divide both sides of an inequality by a negative, you must flip the inequality symbol. Okay? So I have flipped it, and now I have the inequality that says x is greater than 3/13, or 3 over 13. So to graph it, draw myself a little number line. I have the critical value of 3 over 13. No, I do not need you to put 0. I don't need you to put 1. You could if you want to, but you don't have to. And for this particular inequality, it says that x is strictly greater than, so I'm going to use parentheses, and greater than 3 over 13 is going to be all the numbers to the right. Okay, so the last step here is to now write the answer in interval notation, so parentheses, 3 over 13 to infinity, and you close the inequality, or not the inequality, close the interval, sorry about that, with a parentheses there because of infinity. Okay, so that's the first problem. All right, so distribute out a whole bunch of stuff at the beginning, combine some like terms. As I said, you can then make a choice of whether you move the variable to the left or the right. My recommendation is to move it to the left, but that is entirely up to you. We divided both sides by a negative. Because we divided by a negative 13 in this case, we needed to flip the inequality sign to accommodate that negative division. And then we graphed it, and from the graph wrote the interval. All right, so that's problem number 1. I'm going to slide on over to problem number 2 here. Please do not get worked up because you have some fractions, okay? The nice part about problem number 2 is, yes, you have fractions, but we also have a common denominator. That's not hopefully too bad to find. 3, 4, and 6 all have the least common multiple of 12. So I'm going to take every one of these pieces and I'm going to multiply it times 12. Now, because I'm multiplying times a positive value, this inequality symbol does not change in the slightest. All right, so 3 goes into 12 4 times, so I'm really just multiplying this first numerator times 4, minus 4 goes into 12 3 times, so that's going to be negative 3. Be careful with the negative distribution. 2n plus 1 greater than 6 goes into 12 2 times, So 2 times 1. And now we have a problem that's just like that first problem. We need to distribute, simplify, collect all the like terms. All right, so 4n minus 4. Negative 6n minus 3 is greater than 2. So negative 2n, what is that, minus 7 is greater than 2. So negative 2, and I'm going to add 7 to both sides, is greater than 9. Now, again, I am dividing both sides by a negative at this point. So I'm going to write n is less than negative 9 over 2. I'm perfectly happy with you guys leaving the answer as a fraction like this. So, in fact, I would want you to graph it. Negative 9 over 2 is the only critical value we have. That's fine. But in this case, I want to be less than that. So I'm going to go parentheses and aim to the left, okay? Because all these numbers to the left would be less than negative 9 over 12, over 2. I don't know where I just said 12 from. Sorry about that. So interval reads from left to right. So we're going to do negative infinity to negative 9 over 2, use the parentheses, and there is the interval for problem number 2. So yes, you had fractions to start with, but the very first thing we want to do is, in this case, because our denominators were numeric, to get rid of those fractions. Okay, and that's just multiplying by the least common multiple, LCM. Problem number 3 is just like problem number 2. We're going to deal with the least common multiple. In this case, our denominators are 6, 5, and 15. So the least common multiple of those is going to be 30. So I'm going to take 30 times my first fraction, 30 times my second fraction, and 30 times my last one. Okay. So 30 goes 6 to... Hold on, let me say this in the right order, because I've now changed up my order twice here. 30 divided by 6 is 5. So we're going to do 5 times 2n plus 1, plus 30 divided by 5 is 6. So we're going to do 6 times 3n minus 1, greater than or equal to 30 divided by 15 is 2, so 2 times 2. Again, we've eliminated those numeric denominators, which is awesome. So at this point, I'm going to distribute and combine some like terms. So 10n plus 5 plus 18n minus 6 is greater than or equal to 4. So 10n plus 18n is 28n minus 1 greater than or equal to 4. Add 1 to both sides. So 28n is greater than or equal to 5. Divide everything by 28. Now, I'm dividing by a positive number, so I do not flip that inequality symbol. It's just going to stay greater than or equal to. And I am perfectly happy with 5 over 28. Don't feel like you need to get a decimal value for that in the slightest. All right, critical value here is 5 over 28. In this case, n is greater than or equal to, so I'm going to use a bracket here. And greater than 5 over 28 is going to shade to the right. So we would be starting our interval at 5 over 28 and going to infinity. Let me actually try and draw that infinity a little bit better there. All right. So I'm going to go ahead and close out the video here for the linear inequalities. There will be a second video on absolute value inequalities. As always, send me any messages with any questions or concerns you have on this video.